My name is Kelsey Jarecki.
I'm Changji.
This is Lab 9, diffraction.
And our TA is Zuzana.
The purpose is to qualitatively observe diffraction patterns of various shapes and sizes of apertures. We do this by using this collimated laser light to go through the aperture through this lens to a camera, as shown in this nice picture.
And we know in the Fraunhofer region, the Fresnel number is less than 0.1. So we can use this equation to calculate the distance at which Fraunhofer region begins.
So this is where the 168 micron single slit aperture is at the Fraunhofer region. And it has a high intensity right in the middle, and then local maximas going out, getting dimmer. As we move the camera closer, we get to the Fresnel region, and you can see the Fresnel zones in between, like little lines. These are the diffraction patterns in the Fraunhofer region. Notice that as the aperture gets smaller, the pattern gets wider.
This is a diffraction pattern with a double slit of 40 micron. With the increase in separation, there is an increase in peaks. We have 80 micron slit. We receive the same pattern.
So this is the complex apertures at the Fresnel region. It looks like the shape that it is, that the aperture is. At the Fraunhofer region, it looks like the shape but with Fourier transforms.
At the Fresnel region, we could say the circular aperture have the Fresnel zones. In this part of the lab, we try to quantitatively explore the Fraunhofer region diffraction. The setup is the same as what we did in the previous lab, but this time we use 200 by 400 rectangular aperture. And then we input this image into MATLAB. We normalize the data into the sinc squared function. And here is what we have from the MATLAB plot. And we measure the first and second maximum in x and y directions. And these are numbers from the sinc squared functions. And these are the percent error. Percent error are around 20% to 30%, which is consistent. And we can predict the error might be due to the camera is not on axis, or because we are not exactly in the Fraunhofer region.
We did the same thing as the last part, but we used a circular aperture. We found that the amplitude of the first maximum is 7.9% different. At the second maximum, we found that there was a much greater difference between the raw data and curve fitting.